Okay, this is the next part of this question here. It shows that what we're supposed to do is calculate the size of this angle theta here, but we know the gradient of this line. And if we go shift 10, it's -1. We go shift 10, we get this angle here, which is -45 degrees. And since this is 90 here, that means that theta must be 45 degrees. And that's all there is to it. Theta is 45 degrees. Now, the next question. If you know the coordinates here are 5/2 and 1/2, show that this line, CF, is perpendicular to this line, which makes it the height. If it is, it's a perpendicular distance. Well, all you got to do is find the gradient. So you go 1/2 minus 3, the change in y, over 5/2 minus 1. And you get 3/2 over 3.5 over 3.5, another 3.5. When you divide those two, you get 1. And hey, 1 times -1 equals -1. And that's a condition for making two gradients perpendicular to each other. So CF is perpendicular to AD. That means that CF is the height of this trapezium. Now, if you know the area of a trapezium, you can break it down into triangles and do it just as well. You can have two triangles and get the base of one, the base of the other, and you can work it out that way. I think it's a little bit easier. We already know that this is A and this is B, the two sides of the trapezium. We know this one's 3√2, but let's figure out the height first. And all we have to do is find the distance between these points. We put it into the distance formula, and our calculator tells us it's 7√2 over 2. That's the height. Okay, we've got that. We know that A is 3√2. Well, what's the distance B? Well, we know P is 5. We just put it into the distance formula, and we get that AD squared. When we use the distance formula, we get AD squared is 72. The distance is 6√2. Well, now we've got A, we got B, and we've got H. We just put it in the formula. There's one side, the shorter side of the trapezium, plus 6√2, that's 9√2, times 7√2 over 2. Well, √2 times √2 is 2 divided by 2, so you got 63 divided by 2. That's 31.5 square units. That's the area of this trapezium. Like I said, if you forgot the area of a trapezium or didn't know it, you could do it with triangles and it would work as well.